Very good morning to all. So it's my privilege to introduce our chief guest, Sri Sumant Parimal sir. Sumant is a senior industry analyst, consultant, and an entrepreneur with 25 years of experience in global in business and market analyst, industry research, consulting, project execution, and operation in reputed firms. Sumant worked across the global in markets like North America, Africa, Europe, Asia, including India, and he has also done innovative and unique projects in business, techno-economic and management areas in BFSI, infrastructure, smart city, energy utility, water, wastewater management, manufacturing, retail, supply chain to high-tech sectors. He has also worked as a chief analyst of several research. He researched and his research and track industry, markets and economic trends of industry sectors like BFSI, infrastructure, smart city, energy utility, water manufacturing, etc. Sumant also mentors startups of Silicon Valley, California, New York, Boston, Bangalore through his analyst engagement programs covering economic and market insights, industry trends, and advising them on emerging innovations and business strategies. He also advises CEOs, CMOs, CTOs of market distributions, technique innovation and adaptation and strategies. Sumant has managed a global team of professionals spread across the world. He also business partner of a US-based company, Start Consulting Services. He worked in reputed global analyst firm IDC as an Indian advisory head. He was founding member of global consulting practice Enterprise Transformation Services of HCL Tech. He was also deputed in USA by sister concern of HCL America, etc. He was also working with consulting wing of SAIL CET Ranchi, and he started his career as a management trainee of SAIL Maharashtra PSU of Government of India, where he led the biggest technology modernization projects of India in early 90s, and also helped in strengthening the steel industry in India. Sumant attended GIS Manager Training Program, Government of Germany. He is a panel of global experts where he has been featured as topmost through the leader of market innovation, inventory management. And he is invited to repute in institutions like IITs, MDI, IMT, FICCI, Indian Railways, and industry events of analyst talks. He is an MBA General Management. He has an MBA General Management from XLRI, Jamshedpur, India, and holds engineering degree in electrical and electronics engineering from University of Mysore, India. He has also attended MTech MS in electrical engineering and NIT Bhopal, India. So I welcome you, sir, once again for this international conference ICTC 2020. And I request you to please address the gathering, sir. Over to you, sir.
Thank you. Thank you so much. And thank you, JNNCE, Shimoga, and NES for inviting me in this conference. Getting, as a chief guest here, it's my privilege. And since I studied here at JNNCE Shimoga, I'm an alumni of JNNCE Shimoga. So it's like a blessing coming to me. And at the same time, I'm very happy to see these kind of conferences are now getting organized very frequently in JNNCE Shimoga. I thanks Principal HR Mahadev Swami for taking such kind of initiative and kind of linking me with these all programs. And I also like to thank you, the Secretary Nagaraj sir, for gracing this occasion and encouraging these all initiatives in JNNCE Shimoga. And without your blessing, these initiatives would have not been possible. So, I mean, I'll in this my inauguration speech, I have to say that today the world is looking for the engineers, particularly engineers coming from IT and telecommunication background, because this pandemic has thrown a lot of challenge on the communication infrastructure, on the apps, and in the entire computing infrastructure. So I think when we are doing this conference, of course, our syllabus and our study materials are actually designed keeping in view the legacy of the technology. But now, JNNCE Shimoga and other participating institutions should innovate on the the technology cycle, so that the latest challenges thrown to our world being getting addressed. If you see some of the statistics which I'm going to walk you through my key presentation, during last few months, we all were managing through these virtual meetings to whatever work we were kind of performing remotely. And this kind of virtual meetings and the remote working or work from home has thrown the entire telecommunication network and the IT infrastructure, including the computing infrastructure, to a testing mode. And some of the infrastructure they delivered well, and some of the infrastructure they were constrained. And this had the time to discuss where these all the improvement scope can be addressed, and how it can be addressed, what kind of solution we should come up, to address these constraints what we observe. And it's good that the times like pandemic outbreak, like what we are facing right now, brings the testing waves, through which our in architecture, our own design philosophy, our own, the technology underneath gets tested, whether we are for everyone, whether we are available for everyone, whether we are available at everywhere. So if you see, the digital divide has been very, very vigilant during this time of period, So it's not only in India that digital divide has happened, or being faced. Even around the world, the digital divide has been seen. It has been seen in US, it has been seen in Europe, it has been seen in India also, because many of the services deliveries, including the education sector services delivery, moved to completely online mode, which of course earlier in pre-COVID era, people were doing some kind of online education and online courseware uh, to a certain extent, but they were not doing 100%. This pandemic has actually made this transition from there is a requirement of 100% digitization. How the telecommunication infrastructure need to be enhanced for 100% digitization, how the app infrastructure need to be enhanced, how the cloud infrastructure need to be enhanced, how the computing. I mean, I'll like to say, when I visited JNNCE Shimoga last February, we were discussing, even in the pre-COVID era, what kind of computing constraint the world is facing. The silicon has been constrained, the chip we were using so far since last 70 years, these these are already crippled by the capacity constraint. You can't module and integrate more and more transistors, going forward, because the saturation has reached. So world is looking for the alternate computing. World is looking for the enhanced communication. World is looking for the simplification and access of the computing in resources, and the communication resources, telecommunication resources, how the connectivity can be delivered to everyone at any terrain, be it the earth, be it the space. So I think in this conference we look forward how to make the entire technology ecosystem, particularly the computing and the telecommunication ecosystem, unconstrained, so that the future world do not face any constraint, and then do not face any disruption what we are seeing today. And it is a great pleasure here joining here as a chief guest, as well as I'm going to deliver one structure presentation later on this session. And I would like to thank HOD, the Electronics and Telecommunication Department, Dr. Usha Devi. I like to thank the other faculty members and the organizing team. I also like to thank the participants who have joined here. And I wish for a good learning in these conferences. And I see a lot of papers are going to be presented. And these are the opportunity when institutions like JNNCE come up with a thought leadership of not only 21st century, but also for the going for the next 10 years, 20 years, how the entire technology world will evolve. These kind of thought leadership we are expecting from JNNCE to deliver in nowadays, when the world is looking for a next revolution in the technology. And with these words, I would like to thank you again, the organizers and NES management. I thank you, Principal JNNCE, for giving me this up, inviting me and here, and I mean organizing this conference. I wish all the best to this conference. Thank you. Presentation again. I'd like to thank you, the organizers, JNNCE, Shimoga, NES management, and all organizing team member to organize on inviting me on this conference, ICTC 2020. And it is a great privilege to join you people here through online mode, you know. And as I said, this is the testing time. In my opening speech, I said this is the testing time for the telecommunication infrastructure and computing infrastructure. At the same time, this is the time which actually to give credit to this community who actually built the initial generation of the telecommunication and computing infrastructure, which are making the humankind to collaborate and work even in this pandemic situation. Imagine a situation 100 years back when the similar kind of pandemic outbreak happened during 1919. You know, I mean, the telecommunication, such kind of telecommunication and collaborations infrastructure were not present at that time. The impact on the mankind were very, very high, not only from the health perspective, but also the loss of work which mankind seen during those times. So at least from that perspective, in this pandemic, we were kind of delivering some of our work, some of our activities using these telecommunication and computing infrastructure. So we can say that we are not completely in isolation, and we are not completely incurring the losses, but to a certain extent, we are also being productive in these tough times. But at the same time, the systems have been exposed to the extreme conditions. So the professional like you should take it as a challenge to improve and enhance these systems for next generation. So, I mean, I want to mention here in my presentation some of the disruption points what we have observed since last year and even during the last 6 months. So I mentioned about the one critical disruption which the computing world has actually observed in last 2 years is the end of Moore's law. So that is established that Moore's law is not going to work. So it's disrupting the computing. The traditional chip makers are clueless how to increase the speed of computing, which has been demanded by the new generation application like streaming application, AI application, machine learning algorithm applications. So so that the world is working for the futuristic computer. I think when I visited the JNNCE Shimoga last February, we discussed with the various faculty members and along with the principal sir and secretary sir, the computing problem the world is facing. That problem is still intact. The world is working for the futuristic computing. So where we stand, where the JNNCE stand in that problem. So we propose certain thought leadership that computing should be very, very simplistic. It should be available everywhere. It should be available, you know, at any time. You know, so we focus on starting a research program across the year computing. In my talk later on, I'll come to that point. But the scope of improvement of computing is there. You know, we all should work on that, the futuristic computing. Another disruption point, which I mentioned in my inauguration speech also, the digital divide is coming very widely during these lockdown periods and the restriction periods due to COVID-19. You know, in this news media clipping you have seen here, Indian education can't go online. Only 88% of whom with young members have computers with a net link. So Nagaraj sir was also mentioning in his inauguration speech, particularly the rural area and the low income households of Indian households are facing these kind of problems, where their wards are not able to attend the online schools or online classes because either they do not have good connectivity or they do not have any good computing resources. So when you combine these both, you will find that only 88% of homes with young members have computers with a net link, you know. I mean, some of them are using the mobiles, but mobiles are not displaying. I mean, they are not good for interacting with the e-learning environment for a longer period of time. Now, this problem is not only restricted to India. If you see this BBC News clipping, what it said, digital property in schools where few have laptops. So this problem been faced in Europe and England also. So say this is the authority, Mr. Wayne Nori. He's the authority of British education system. What he's saying, in our school, 60 to 70% of children would not have laptops. So the problem persists across the globe. Even in US, you'll find in certain tribal states like Washington, there is a problem of net accessibility. You know, they're totally isolated, got isolated during this pandemic crisis. So next disruption point I would like to mention here to highlight all of you is the pressure which is coming on the telecommunication infrastructure, particularly the internet infrastructure. So if you see the Indian perspective, the average network speed in peak hours since India lockdown down to 36% versus what we were observing in February 2020. So this is another analyst firm, Tutela. They found this in a study, in a data crunching study, that the speed of the Indian internet system gone down during these periods. So that means there is a lot of scope of improvement in terms of capacity augmentation, in terms of technology enhancement. And this is not limited, again, this phenomena is not limited only to India. If you see the World Economic Forum update, the internet is under huge strain because of the coronavirus. Experts say it can't cope. It can cope for now, but I mean, it is still not crash, though it is coming under the huge strain, but it has yet not crashed. So that thanks to the earlier designers, though it is not full kind of catering to the whole world population, but in that 50%, 60% population who are accessing the digital communication or data communication through the internet, at least they have not facing very frequent crash. They are facing the speed constraint, capacity constraint. So, but one thing is quite sure, the present internet and present data communication network is not capable of handling this pandemic kind of situation, you know. And also, suppose if tomorrow the digital penetration goes on, that is like if 100% of the population gets digitally covered, then the present backbone of the internet will not be capable enough to handle those kind of loads, upcoming loads. So I think this is the time when we have to design the next generation of telecommunication and internet infrastructure. You know, the signals are very clear. You know, if you study these events which has happened in past few months. Now, when I come to particular telecom, now we were mostly focusing on the internet side of it or data communication side of it. When we come to voice communication, telecom, then there also the lot of stress has been observed during these 4-6 months of COVID period. What we have seen, because most of the people were working through home or you know, online environment and ordering the online stuffs. So they are doing a lot of calls for their personal uses as well for their official uses. So high call volume causes network congestion as lockdown looms. So this is not the headline of India only. This is the New Zealand headline also, which is a less populous country compared to India. So what I'm to say, globally challenges are same. There are some sectors where India is better. There are some sectors where the other countries in the world are better, you know, but the challenges are almost same. Now in India, if you see during the COVID disruption, the many telecom providers, they have actually asked for the extra spectrums from the government of India to cater to the increased voice and data bandwidth requirements. So the stress is already there, but government is not quick in releasing those extra bandwidth. The bandwidth, the spectrum auction is a long process. You all know how it happened. But now the researcher, as well as the telecom providers, as well as the institutions like JNNCE should work with the regulatory institution of Government of India like TRI to find out how much extra bandwidths and extra additional spectrums need to be released for catering such kind of peak data and voice calls, and what are the modalities for that? I mean, they come through the auction route. So a lot of legal frameworks are there, and where the spectrums are there available or not. Why the government is not releasing the spectrum? Because most of the spectrums are reserved for our defense forces or our other forces, or some kind of area where government actually want to make sure that the spectrums are dedicatedly available for their programs, or some kind of emergency work they used to carry, like disaster management. So I think these are some of the area where the researchers should also look in how to manage with the less spectrum, or even they need the extra spectrum, how to get it, how the government will manage with the less spectrum in that case. So I think spectrum management in other area where industry and research institutions like JNNCE should also collaborate and come up with the thought leadership. When we are coming to the app, so we discuss computing, we discuss internet, we discuss telecom. Now let us also discuss the app aspects. So apps were also stressed during these time. These are the testing periods of many apps. We all use WhatsApp. So WhatsApp has seen 40% increase in usage due to COVID-19 pandemic. Facebook says coronavirus is pushing users through the roof, but its business is hurting. So they have here the ultimate thing has happened with Facebook. Their one-to-one chat or video chat application, they have seen that tremendous increase in users, but the business have not grown up. So what is the best model to monetize, the increased usage of apps with the revenue generation? If the consumers are using more and more apps, but the app providers are not generating any revenue out of that, then will not be a sustaining model. So researchers like you should also come up with the idea, when the apps and network uses are going up, then how to monetize it also, so that the telecom players should sustain, the app providers should sustain, because they have to put higher resources, they have to purchase higher resources, they have to deploy the more manpower, So I think these are some of the points which I wanted you to look after, during this conversation. Okay, let me go to the next slide. When I discuss the computing, because computing disruption is happening since 1 year and 2 years down the line. It's not a new phenomena. Of course, this, excuse me. Of course, the other disruptions we recently observed, but computing is a disruption which is happening since last 2 years. So I discussed during my opening also that the silicon is no longer our future. We have to think beyond silicon. What is that beyond silicon? So the quantum computing is one aspect. I think last week we had a faculty development program in JNNCE where the quantum computing was a subject, and it is a very great initiative of JNNCE to organize such kind of faculty development program and on the latest technology. So quantum computing is a way how you can, it is a way to handle the bits and bytes restriction, right? But it's not actually solving the problem thrown by the silicon constraint. Still, some of the quantum computers are getting implemented on some other alternate computing resources. They are not getting implemented on silicon, but I'm sure many of them try to implement it on silicon also. So it's actually a methodology to go beyond bits and bytes. So bits and bytes, bits in bits you have the restriction. You represent only 2 states. But in quantum computing, you go to qubit. So if you see qubit, let me come to the next slide. So qubit, 2 qubits, 512 bits. Similarly, you can see if you go to 100 qubits, so it means that more than all the atoms of the planet Earth, to be in the traditional computing, it required to represent 100 qubits. So definitely it's a way to represent the state. So a qubit represents many more states compared to bits. So in that way, they are enhancing the computing. But as far as the computing material is concerned, the medium is confirmed, they are not uniform. Like IBM, they are doing on superconductors. Similarly, I'll mention some of the other inventions happen in quantum computing who are doing on the photonics. So still world has not converged what the computing medium should be for the future computing. So if you see, we are actually transitioning for 4th generation computing to 5th generation computing, which is the quantum computing. So this is where we have to actually manage the computers or evolve the computers which are 100 times faster than what we are seeing today. So when you design any computing system for managing the futuristic computing, I think these 4 factors you should keep in mind. It should be able to handle the large volume of data. It should be able to handle at the larger speed or the greater speed. It should be able to handle at a low cost. The cost should be also low. Then only it can become affordable, as the Secretary Sir was talking, especially about making computing accessible to our rural population. They have the huge cost constraint there. You can't increase the cost of access. The kind of research money being poured by IBM in quantum computing, I think they are still very costly resources. We can't say that quantum computing being developed for the masses, for the rural population. So when you develop a new computing methodology and system, you have to keep in mind that it should be cost effective. It should be accessible. It should be available anywhere. If you see IBM quantum computers, they are again looking like the legacy big frames, occupying a big room with a lot of coolings. And I think in this presentation, I'm not walking through the videos of quantum computers. I think last week I delivered a presentation where I shown the video of IBM quantum computers also. They are occupying the big rooms. They are being cooled by, the coolants, which are very bulky. And there you need to maintain a temperature which generally we find at in the space that is below the 0 degree. So I think it is good that quantum computing is actually a fast computing compared to what we are getting the computer by using our processors, microprocessor, but I think we need to evolve a lot. This quantum computing is good in this methodology in terms of how the bits have been transformed to qubits and how they handle the higher quantum stages in each data, but they are not good in terms of giving it a low cost access in terms of giving its accessibility anywhere. So I think these are the area we need to work further. So I'll come to the some of the points I already discussed, that Google also achieved its quantum supremacy, and last year in November they claimed that they went above the supercomputers. They actually achieved the higher speed compared to the fastest supercomputers, you know. And similarly, IBM, they have planned 1,000 qubit quantum computer by 2023. Right now, I think they have around 70 around 70 or 60 qubit computers operating. You know, they have 18 computers, quantum computers in their labs. I was talking about the first for photonic quantum computing. So it is good thing that the race towards futuristic computing is not limited towards one media. You know, earlier the race towards computing were only, you know, integrating more and more transistors on silicon wafer. But now it is good that world has actually moved beyond the silicon wafer. The researchers are now looking for alternate computing media. So as I said, IBM built up its quantum computer on superconductors. But see, this Toronto-based Xanadu, so they are building their quantum computer on photonics. So this is the great innovation. Okay. So similarly, some other players are doing some research on some other media. So other medias which are getting research for its application in the futuristic computing are wave computing, laser and optical computing. And I was foremost in coining a concept or air computing at the 5G research, and then later on, when I came to JNNCE Shimoga, I actually kick-started a research program in collaboration with JNNCE Shimoga, which is how to make a computing possible by using air as a media. Is possible. Is air conducts the signals, the waves. You know, all your many telecommunication signals goes through air waves. So that means air being already utilized for handling the data. So the data manipulation is getting done on air. So why, I mean, what is, after all, what is the computing? It's also the data manipulation. So when you are communicating, you are doing data manipulation and data transfer using air as a media. I mean, Ethernet, you call it Ethernet, the old Ethernet. So why can't we do computing via the air? There's the question. How to develop a technology, suitable technology? I know today technology is not there. But imagine a world where air delivers the computing, then that will be the day where computing will be available to everyone, because air is there on the planet, everyone, everywhere. You know, even we go to space, we create our own artificial air. You know, so if the air computing is possible, then the present constraint of the inaccessible computing to the masses will go out. It will be low cost computing, hopefully. You know, we have to research it. We have to find out how to make it a low cost computing. And it is going to be computing anywhere, everywhere at a low cost with the less complexity. You don't need a separate storage media. You don't need a lot of wires to connect to each other. You know, you use the air wave itself, or maybe say the atomic particles available in air itself to store your data. So next revolution in data storage will come there, where you don't need to carry the silicon USB devices or the you know, the thumb drives or the bulky storage media. You know, you access it like you say cloud computing, but cloud computing is actually not a, you know, originally cloud. It's actually depending on the silicon media and a lot of networking things. So can we simplify the thing? The world is looking for the simplification of computing. I can view my screen in air anywhere. I can listen to the phone call anywhere without any complicated instrument anywhere. You know, how we can simplify this telecommunication, where a person concerned can intercept the signals passing in the air without any complicated devices. So while the researchers should look for innovating new technology, I mean, in Indian this thing Mahabharat, and I'm not though I don't remember each and every instance of Mahabharat, but it has been told that Arjuna, by getting when he was getting a lesson of Bhagavad Gita by Krishna, I mean, a lot of images were shown to the Arjuna by the Lord Krishna. So how those images performed? There were no infrastructure, silk infrastructure. I mean, it was just delivered through air. You know, they went in past during the Bhagavad Gita conversation, and they saw the, you know, like what we watch in our TV, you know, some kind of past film. But if you see those imagination, we can say today the imagination, but you know, you never know, you know, in those periods the technology could have existed for such kind of simple delivery of the contents. So I think our the old textbooks like Ramayana and Mahabharata, they have very good references of simplification of technology. I think when we research, we have to look all these kind of literatures where the technologies were when the past generation were discussed, and how the simplification can be done by leveraging those you know, those artifacts. I'll come to the what's happening in presently in the data communication. So what I spoke in last slide about delivering the computing and communication through air computing is, I mean, is a matter of research. It may take some years, but what's happening right now to deliver internet to all is the low orbit satellites network. So it's not only one company which is delivering or trying to deliver the computing to all, but many companies are in the race. These are the different companies. These are not the traditional telecom companies. If you see, these companies are SpaceX, started by Elon Musk. If you see, Airbus is building the satellite network. If you see, Facebook is building the satellite network. So these are not like Telestral and typical like the Reliance Jio or Airtel or Vodafone kind of world. There is a different player coming in this space, but all of them the same vision: make internet accessible to everyone, even in the remotest part of the world. So the world is working on the problem of internet penetration. So SpaceX just in last week, they have launched some 600 satellites under their program known as Starlink. So thousands under this program, the thousands of satellites will make up a network called Starlink. So SpaceX is planning to start beta testing Starlink for some people who sign up in US and Canada. The satellites could make the internet 40 times faster. So if you see this design of the Starlink, where they are going to place maybe thousands and thousands of low orbit satellites, which are just 500 kilometers above the Earth surface. So they are not only trying to address the accessibility constraint of the internet, but they are also trying to address the speed constraint on the internet. At the same time, they are very much aware about the cost aspects of internet. Though they are launching the satellites, but at the same time, they want that their internet services to be very cheaper. They are targeting, some of these players are targeting to provide internet connectivity through using their satellite network at as low as at $80 per month, which I think many of us are still paying. So Elon Musk Starlink is giving high-speed internet access to remote Native American tribes. So they have recently tested this. You know, I am mentioning that the digital divide in US also. So Airbus has also started its space program, a space satellite program, and this is called OneWeb. So OneWeb, they are building very low-cost satellites. So if you see here, a revolution in satellite manufacturing they have done. No one has ever built a satellite in one day, and what Airbus is saying, we will build several satellites every day. You know. So they are also targeting for the high-speed internet connectivity equivalent to the what we used to get in the fiber optic network or maybe beyond that using the satellite. Similarly, the Facebook is building the low orbit satellite that we call it LEO network, and it's known as Athena. Okay, so they are also building, and they are actually, they have the strategy to make internet accessible to everyone so that they can deliver their Facebook application to the all residents of the earth. Okay, so these are some of the initiative recently happening in recent days happening in the matter of increasing the internet penetration. So apart from these satellite intervention, the fiber intervention is also going on. Other interventions like delivering the internet connectivity through drones, you know, cellular towers, through 5G, those all also you know, the companies are doing that also. Now when we talk about 5G adoption, the 5G rollout has been already started in many countries. You know, in India we still kind of permitting the trials of the 5G. In many countries being started. So as per this forecast, if you see 5G adoption to take off in 2021, you know, so these are some of the subscriptions of 5G smartphone subscription by region which are forecasted. So if you see in 2021, Asia Pacific is going to have the highest subscription of the 5G smartphones. And beyond that also, Asia Pacific is going to dominate the 5G subscription, followed by Europe and North America. So by 2025, it has been forecasted that you will have around 2,500 million 5G smartphones subscription. Okay, so if you see another data, I mean, how it looks like by 2025, the 5G connection as a share of all mobile subscriptions. So we said that in last slide, we said that 2,500 million will be the 5G smartphone, approximately smartphones. And now when you see the share of 5G smartphones or 5G connections, you see by 2025, South Korea is going to have 59% of that share. That means they'll have fewer number of 4G devices compared to the 5G devices. So they are going to be the lead adopter of the 5G technology. That is still as a prediction, followed by US, followed by Japan, China, Russia, you know, and other countries. If you see the speed revolution so far, whatever they have tested, you know, up to August 2020, they tested in Saudi Arabia, in South Korea, in Australia, in Canada, in Switzerland, United Kingdom, Germany, and United States. So if you see the whatever 5G connection got tested in Saudi Arabia, they are delivering the fastest speeds. You know, they have gone up to much beyond 400 Mbps, I think. Okay, so what is the reason why United States is still lacking? I think they are still in trial phase. They are again, I mean, many frameworks they have not frozen up, you know. So I think the smaller countries like Saudi Arabia, South Korea have delivered well in as far as the leveraging the speed advantage is concerned. So, but one thing is clear, all of them are getting advantage of higher speed when they are testing their 5G network. I'll talk about the 5G. I mean, you know, I mean, during the conference, you will be going to deliberate, especially on the 5G. 5G is not only going to deliver the higher speed, but it is also going to deliver many other contexts of the you know, application, like, you know, like in today video conferencing application, you don't view it very good. I mean, in terms of the face expressions, you know, and how do you really meet, you know, those kind of expressions are missing. But once the 5G are going in place, there is a possibility that we will see new form of video conferencing, new form of collaboration apps, which actually which looks very similar that you are doing a actual meeting. You'll have the facial expressions better way. You'll have a kind of touch and look feel. You can have teleporting also, some kind of 3D teleporting possible by using the 5G infrastructure. After 5G, we'll come to the apps, because there also the lot of constraints are getting faced. We've seen the apps are also crashing. If you see, we did not discuss in detail, but during this pandemic time, during the lockdown time, many apps actually face the crashing scenario, because the users grown up. Many of the e-learning apps, many of the Zoom apps, the apps like the Flipkart, the Amazon, the apps like many apps like grocery ordering, the medicine ordering, so they have faced a lot of users constraint in terms of, because everybody was trying to use those apps, so they crashed very often of time. And the problem is these many apps need to be downloaded, and well ahead of time. So there is some movement in apps world also. Now apps, you need to have instant apps. The apps ecosystem is moving from the native app to the instant apps. So hopefully these will address some of the, because in native apps, what will happen, you have to download the mobile applications of each and every app. So suppose now, like we have to attend the Zoom meeting, we also download a mobile app of Zoom. So it's a native app residing in our mobile. So of course it uses higher resources of our not only our computer and mobile, but also of the network, because it remains communicating so many things. So the future is the instant app. So what is this instant app? You don't need to download anything in your mobile like you do nowadays in laptop. You open your browser and you are done. You have access to the all features of the app. Similarly, in mobile is also going to move an instant app where you don't need to download anything. You just need to kind of point your URL towards certain certain pages. You'll get the all interfaces of the apps. So Android is already activated the instant apps, and many companies have actually discarded their native form of the mobile apps, and they have moved to transition to the instant apps. Many brands have actually transitioned. They have launched their instant apps, because if you see the apps abundance is very high. If some company and some brand is working on developing some mobile app and then being not used by the users and consumers, then their investment goes to the waste. So because apps development and as well as installation, its maintenance required a lot of investments. So instant app is delivering a lot of cost advantage also, in terms of speed advantage and cost advantage. Both are getting delivered by instant apps. So Android has come up with the instant app. Any one of you want to develop the instant app, you can use the Android program. I'm not from the developer background, but these are the trend from the analyst background. I'm just telling you that these are the trend of instant apps, and going forward you will not find any mobile apps to be installed on mobile for accessing any of the facilities. It will become very easy for you to access some of the features of a branch. So if you see the app evolution happen in the mobile world, so I was talking about here that we used to have the native apps. Now it is moving to the instant apps. So these are some of the how the evolution has happened, that from native app it's moving to the hybrid apps and micro apps. So when I say instant app, it's nothing but some kind of micro app, right? User interface in apps are also getting evolved. A lot of AI interfaces are coming up. And particularly in AI, in this pandemic area, the lot of emphasis is on the voice related AI, or you can say conversational AI interfaces. Why I should touch a door for opening? Why it's not sense my own movement and open the door? I mean, and apart from there, I mean, you see in many doors are automated in malls and shopping complex, but they malfunction also. So how to improve about that? Can we have some kind of conversational interface where I give the command to my door and it open up, so that people do not touches the door? Similarly, a lot of conversational interfaces are coming for the home management apps, building management apps, a lot of office automation apps are coming with the conversational AI interfaces. So artificial intelligence is one more area where the apps has to build the capabilities. You can't ask a user always to feed the data regarding certain requirements or certain attributes. I mean, the apps should be intelligent enough to extract and to judge the requirement of the user, its user. What is the user is needing it. Now, why don't my apps understand at what time I need to switch on my WhatsApp application, and what kind of conversations are going in my group, and why don't they just in morning they just send me somebody reports that these are the conversations happening in your WhatsApp group and suggest for some recommended reply. Why can't my apps AI engine catch ups my preferred preferred way of working, or say suppose or preferred way of purchasing. Suppose I'm doing some transaction on e-commerce website, then my app's intelligent AI engine should know what should be my next item to be ordered, or like how frequently I consume a particular item, and they should able to suggest that last 10 days you did not order this item, probably it might have exhausted in your kitchen or in your wardrobe, right? So they should suggest. So a lot of AI interfacing, AI capability need to be built up across the your apps. Suppose if you are developing the app. Another trend which I think many of you might be doing some blockchain development also. Many of them have become the Ethereum developers. So by the introduction of blockchain, it is now possible to deliver the distributed apps. So distributed apps will address the congestion which we are facing on the centralized apps. Like I mentioned that the many of the centralized apps like Flipkart, Amazon, they were kind of extremely loaded during this pandemic period because these all are centralized apps. Distributed apps will disrupt these all centralized apps, and they will be the tiny apps sitting on each and every nodes, and they will deliver the required artifacts and required functionality which are actually required for suppose ordering something or doing some functions. So the blockchain itself is a technology which will disrupt the monopoly of the platform ecosystem which we have. Right now we have a monopoly of Facebook, we have the monopoly of Amazon, we have the monopoly of Flipkart, the Alibaba, these kind of even Book My Show, the streaming apps like Netflix, they were extremely under the monopoly, and they were extremely pressurized. Many of the Netflix these things servers, I mean they kind of reduce their picture quality to cope up with the present load and the demand they are coming from the consumers. So once you migrate to the blockchain and distributed app architecture, these kind of resource loading on centralized infrastructure will go down, because the DApps will deliver the required functionality directly between the two nodes. You don't need to have a middle node, or you don't need to have a negotiation layer or a middleware kind of thing, right? So it will, if I am a need of a content, and if this content is available with a person Y, then I'll be directly dealing with the person Y. I won't be going through the Netflix to procure or to fetch that constraint. So that is the advantage of the distributed platform which the blockchain is delivering. The blockchain will also require the new paradigm shift in the telecommunication infrastructure, because a lot of data mining, that is blockchain mining applications runs, which consumes a lot of bandwidth. So when you are designing or working on the next generation of the telecommunication infrastructure, do calculate what kind of the new network loads are going to happen through the blockchain application on dApps. The token mining, you must have seen, the Bitcoin mining. These are the very resource intensive applications. They not only eat the computing resources, but also eats the network resources. Then, the network latency should also be less for running the blockchain applications, because the blockchain applications runs across thousands and thousands of nodes at one go. So if you have a latency, then the transaction will get delayed, because a lot of authentication happens using the blockchain and smart contracts residing on the distributed application. So I think the telecommunication engineers should look up the entire blockchain ecosystem, how it is evolving, and how to make the next generation of the telecommunication infrastructure for incorporating the bandwidth demand and data communication demand getting thrown by new blockchain applications, which we are calling here the dApps, distributed applications. Now, when we go towards the end of my presentation, I'll mention these all technology will not exist in isolation. These will operate in convergence. So when you are designing your technology, you need to work on the convergence aspects. Okay, so what I predicted in 5J was that the most innovative areas are not only AI in individual as an individual technology, or blockchain as an individual technology, or say IoT as individual technology, but most innovation will happen when we build applications by converging these technologies. So what the convergence we call convergence of blockchain, IoT, and AI, that is CBIA. What it means? It means that IoT resembles the nervous system of a mind. Like if you see in this diagram, there is a mind. Mind is what? Mind is the convergence of three things. These are nervous system, and the reasoning, and the human memory. The memory. Similarly, if you converge your technology like IoT, Internet of Things, AI, and blockchain, then you will going to build a mind very looks like similar to human mind. So this is a logical representation of how the convergence should happen. And if you see in this diagram, I've shown how blockchain, IoT, and AI is converging to form a CBIA. And this is the most innovative and disruptive layer, right? Most happening area. Most of the values getting created in this area. The values like a smart contract, connected insurance, autonomous commercial agents, automatically disaggregating and reaggregating products and services, distributed apps. In future, sales will not be done by the human man. In the future, the sales will be done by the virtual agents. They will be generating their own terms and condition and rates to close a sales deal in a real time, and that the closure may happen in the midnight. As a managing director or CEO of the company, I may not be even aware that some closure of the contract has happened in the midnight. These are the smart agents will work in background to ease out your the sales, the processes, and the marketing processes, operational processes, and these will happen with the convergence of blockchain, IoT, and AI, which we are calling CBIA here. So these all converged technology are making us to see a new paradigm in the web, which we are calling it Web 3.0. Right now, we are mostly in the Web 2.0. With these conversations, we will be moving to Web 3.0, which is going to be intelligent web, trusted web, and the meaningful web, having the omnipresence presence in all channels. Even the enterprise architecture is going to shift. This shift, we are calling it EA2 shift. So this is how we have predicted the enterprise architecture will shift. It is no longer a centralized database. It no longer a centralized app server. It no longer centralized the cloud servers or cloud infrastructure. It's all going to be distributed. And as a node operator, I'll become owner of those content. It's no longer that the Facebook will become the owner of my content. You know, I will own, I can monetize my own content. I can sell in market. I can monetize my own data. I can sell in market. You know, I can directly sell my stuff to those who are needy. So the blockchain is also changing the paradigm of the enterprise architecture. You know, these all centralized enterprise architecture we had. We have the bulky database servers. We have the bulky application servers. Those all will move to the distributed application architecture, right? If you see, I said that these two will be coexist. The bulky EDI, the electronics data interchange, they will also disappear. They will also disrupted by the blockchain-based communication system, node-to-node communication system. Similarly, middleware to also go out from the ecosystem slowly and slowly. So these are some of the predictions. As a researcher, I like to bring to your attention that how the evolution will happen in the entire enterprise architecture landscape, and ultimately the communication backbone need to be aligned with those disruptions. With these words, I like to thank you again, and I'm ending my presentation. I think I've taken some good time, but this is a really very good opportunity for me to interact with you all and present my thoughts on how the evolution, next evolution will happen in computing and telecommunication space. Those